we go with example number 3. And remember what we're doing with these examples where you have trig stuff on the left equals some sort of trig stuff on the right. Our job is to verify. What that means is we want to take one side, usually we're going to take the left side, or you take the more complicated side, and we're going to do whatever kind of algebra type stuff we need to do to make the left side look like the right side, to make this stuff over here, this complicated stuff, somehow look like negative tangent squared x. And we've got to be able to justify our steps every single step of the way. So the first thing I want to do is look, when I look over here, there's a whole bunch. Over here is one piece. So my first thing is, let's look in that parenthesis, and it says tangent squared x plus 1, which is the same as 1 plus tangent squared x. And that's one of my Pythagorean identities. 1 plus tangent squared x equals secant squared x. So 1 plus tangent squared x equals secant squared x. That's just one of my identities on the sheet, except for we've got it flip-flopped. That's the same. So I'm going to take this right here, and you're allowed to turn that into secant squared x. So that is the first thing I do. Now the second says cosine squared x minus 1. This one's a little weird. I'm going to write out the identity sine squared x plus cosine squared x equals 1. I want to make it look like cosine squared x minus 1. So I don't want a minus cosine squared x over here. That would make 1 minus cosine squared x. When you have two things, if you're subtracting them, the order definitely matters. If I say cosine squared x minus 1, I got to have cosine squared x first and 1 second. On the previous one, when I say tangent squared x plus 1, it doesn't matter. It doesn't matter the order that you add two things. Just like in adding, if I said 3 plus 5, it's the same as 5 plus 3. 3 plus 5, or 5 plus 3, both of them are 8. But if I'm subtracting, 3 minus 5 is negative 2. 5 minus 3 is positive 2. So the order you subtract definitely matters. The order that you add does not. So I've got to get this here right. I need to make this somehow look like cosine squared x minus 1. So what I'll do is I will minus the 1 on each side. That gives me sine squared x plus cosine squared x minus 1 equals 0. So here it is. Then minus this over here. So I'll minus sine squared x. And I'll have cosine squared x minus 1 equals negative sine squared x. Like that. So anytime I have a cosine squared x minus 1, like I got right here, I can sub it out and sub in a negative sine squared x, which is what I'm going to do. Now, I don't want it to look like I'm going secant squared x, subtract sine squared x, so I'm going to drop a parenthesis in here. Usually if it's a monomial or one piece, I wouldn't, but because it has a negative out in front, I think I might just. Like that. And now that equals negative tangent squared x. Okay, and what you could do is you could take the negative out now and put it over here, and heck, the negative, that's where this negative is coming from. So I already got that taken care of. So I'll just do that real quick. I'll pull the negative out and put it here, and then I'll have secant squared x, and now I can just write sine squared x. It was secant squared x times negative sine squared x. Well, that's the same as negative secant squared x sine squared x. And that's negative tangent squared x. And keep in mind, this negative sign right here is going to be that negative sign right there. Now my job is to just make these two pieces somehow look like this tangent squared x. So where to go from there? Okay, remember, say that you're stuck. I don't know how to make it look. How do I make a secant sign look like a tangent? If you're stuck, try turning anything that's not a sine or a cosine into a sine or cosine. Absolutely everything. Cotangent, tangent, secant, and cosecant can all somehow be turned into sines or cosines using this sheet. Just so happens that secant squared x is the same as 1 over cosine. So I got my negative, I'm going to keep that. But then this is 1 over cosine squared x. And then here's sine squared x. I'll put my negative a little bit more right there. Equals negative tangent squared x. And now what I can do is I take my sine squared x and this fraction, I multiply them together. Basically the piece out to the right can multiply up into the top, which gives me a negative sine squared x over cosine squared x. And again, I'm hoping I can make this look like negative tangent squared x. All right, and I'm here. Anytime I see sine squared x over cosine squared x, that's just one of the basic identities. Sine squared x over cosine squared x is negative, or is tangent squared x. Then I have that negative right there. Sine squared over cosine squared equals tangent squared x equals negative tangent squared x. Once you got the left side to look like the right side, right here, we are done. Do you want to point one note out in case you didn't catch this earlier or you didn't realize it? Yes, it is tangent x equals sine x over cosine x. That's what you're going to see on pretty much all your identity sheets. You're not going to see sine squared over cosine squared. But this identity right here also implies this right here. If you had tangent squared x, it would be sine squared x over cosine squared x. If you think about it, tangent squared is just tangent, tangent. So you could turn it into sine over cosine, which would mesh together to make sine squared x over cosine squared x.